Hey everybody, Mr. Morel here, and we're gonna start sequences. This is like, I don't know how to describe it. We're gonna spend more time on this unit than we do, I think, any other unit in the whole year. Oh, I got a text message, hold on. Okay, I'm back. Don't worry, it wasn't anybody worth talking about. It was a girl, but she's married and pregnant, so that's not helpful. Um, Anyway, let's talk about math. So before we can really understand sequences and arithmetic sequences and stuff, this is a big vocabulary heavy unit because we're going to be throwing tons of new words at you. Um, oh my gosh, another text. Hold on. Okay, I'm sorry. I'm working on a big group project for grad school, and so my group keeps texting me questions. Those fools. Don't they know I'm busy? Anyway, so we need to know a bunch of vocabulary words this unit. So for these level 1 questions, we've got this word bank down here that's going to help us right there. So let's just talk about it. The natural numbers are the numbers that you count naturally. Like if I ask you to start counting, you would say 1, 2, 3, 4, 5, and they would just go on and on. The domain, we've talked about domain and range before in the last unit. It's the set of all possible inputs of a function. Now, a sequence is a function where the domain is the natural numbers. So what I'm telling you there is we're going to have a function, but the only possible inputs that we can have are going to be 1, 2, 3, 4, 5, 6, and so on. We can't have any negatives, no fractions, no whatever. You guys are going to love that. So that's pretty neat. Okay, a constant difference. In a sequence, the constant difference is the number you add to go from one number to the next. Now, there's going to be examples where you're going to want to subtract, but remember that subtracting a number is the same as adding a negative. So you need to be very careful as we talk about constant differences to make sure you're doing that. So we'll talk about that soon. Okay, an arithmetic sequence, that's pronounced arithmetic, is a sequence with a constant difference. In other words, if you are adding, or it might seem like subtracting, the same number every time as we move from one number to the next, that's called an arithmetic sequence. An explicit function, a function that helps you find a specific term in a sequence just by knowing its position. What that means is that if you've got an explicit function available to you, I could say, hey, tell me the 100th number. And you would plug the number 100 into your function, and you would be able to tell me what the 100th number would be. So let's look at some examples here. Question 7. Yeah. Let's do questions 7 and 9. All right, so here we're just going to look at the sequence, and we want to finish the sequence starting off. So this is pretty easy to look here. 4, 5, 6, 7. I hope you realize the next number is 8. Now we want to fill out the table. Remember, with the sequence, this is our x value. It's the position in the sequence. So 1, 2, 3, 4, 5. So the first number in the sequence is 4. The second number in the sequence is 5. Then 6, 7, and 8. Okay. And now we have a table. We just want to, write the function for that. So like we always do, we're going to find the slope. I'm adding 1 on this side, adding 1 on that side. 1 divided by 1 is 1. And then I need the 0th number in the sequence. So it's kind of like finding the row above this row here. I need the 0th number. Or for some people, they kind of look at the number before the starting number. So if I were to go up a row, I hope it's pretty obvious to see that would be a 3. Or if I went back a number, it would be 3. So my function is 1x plus 3. And we could double check that by saying, hey, what would the fifth number be? Well, let me double check. The fifth number in the sequence would be 1 times 5, its position number, plus 3. Well, 5 plus 3 is going to be 8. And that is exactly what we got. So we know we have the correct explicit function. Let's do question 9 now. Question 9 is a little tricky for some of you, but don't forget you've got your calculators to help you. If you don't know what we're adding to move this way, well, pick a number and subtract the number in front of it. So in your calculator, you could type 1 minus negative 3, and it will tell you a positive 4, because what's happening here is that we're adding 4 as we move this way in the sequence. Okay? Again, yeah, so we're adding 4, and so the only number that could go here would be a 5. And that makes sense because negative 3 plus 4 is 1. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13. Okay, oops. And then once again, we're just going to fill this out. 1, 5, 9, 13. Now, the nice thing, you remember how over here I was doing plus 1 and plus 1, and then I did this number divided by that number? Well, the cool thing about sequences is that these will always, always, always be going up by 1. That's the definition of a sequence, is we've got the natural numbers. So for our slopes, our constant difference is just going to be this number divided by 1, which will always just be whatever number our sequence is going up by. So the constant difference in this example is a 4. And then the 0th number, well, it's the number before the starting number. I would take negative 3 and subtract 4 from it and get negative 7. So our explicit function is 4x minus 7, and we can and should double check that by plugging in, let's try a 5 and see if we get a 15. F of 5 is going to equal 4 times 5 minus 7. Well, that would be 20 minus 7. Wait, I think I did something. Hold the phone. What did I do wrong here? Oh, doi. That's not a 15, that's a 13. We're okay. So I was going to say 20 minus 7 is 13. And that is what we wanted. I was just reading that as a 15. Forgive me. Alright, let's go on to the next page and try a couple more. So here, I kind of take off the supports, the training wheels, and let you kind of just figure these out on your own. So let's see here. All I really need to figure out is my constant difference, because that's going to go here. And then the number before the starting number is going to go here. So let's go ahead and do question 10. So to move from here to here, and here to here, and here to here, looks like my numbers are getting smaller. I'm subtracting 8. So that's my constant difference. So if I'm subtracting 8 to move this way in my sequence, I need to add 8 to move that way. And so my explicit function would be negative 8 plus 8. And of course we could always double check that by checking the position number. So like if I wanted to check the fourth number in the sequence, I would do negative 8 times 4 is negative 32. The negative 32 plus 8 is negative 24, which is exactly what I wanted. Woohoo! Alright, let's go down to question 12. It looks like I'm probably subtracting 2 or adding a negative 2 as I move that way in the table. So my function would be f of x equals negative 2x plus, well, if I'm subtracting 2 to move to the right, I need to add 2 to move to the left. And so that would be a 4 right there. Alright, and question 14. Looks like I'm adding 5. So I know that you want to write plus 5 right there, but you don't need the plus. For the same reason that we don't say, hey, that we're adding a negative 8. We just want to say that the constant difference, that's just a regular number. We don't really want an operation associated with it. It's just a number. It's the number negative 8, or the number negative 2, or the number positive 5. Okay, so it's just a number. Now, we're going to have f of x equals 5x plus, let's see, if I'm adding 5 to move to the right, I need to subtract 5 to move to the left. That would be negative 15. Cool. All right, now level 3 is a little tricky, but it shouldn't be, really. It really shouldn't be. All right, let's do question 16 together. So question 16, notice this x number here is 1, 2, 3, 4. These are the positions. You could see the dots are just in the correct position. And what matters to us is their y value. So the first number is a negative 3. The second number is a negative 2, then a negative 1, then a 0, then a 1, and then a 2. There's our sequence. Negative 3, negative 2, 1, 0, and so on. So our function is going to be f of x equals, well, we're adding 1, so 1x plus, and if I went back a number, I believe that we would see that our y-intercept would land right here-ish. Our 0th number would be a negative 4. So 1x plus negative 4. I bet you could do the rest. You're pretty smart peeps. And yeah, level 4, I'm just giving you a little bit of information, and your job is to fill out all of the rest. I think that's pretty doable. You guys are pretty smart. So I will talk to you later, and I'll see you on the flip side. We're going to talk about something completely new, but I think it's awesome. Okay, bye.